This classification is based on the hybridization of the carbon atom to which the hydroxyl group is attached. In these alcohols, the hydroxyl group is attached to the primary carbon atom of the alkyl group. That is, a carbon atom bonded to one adjacent carbon atom. So what is allylic group? That means you will have a double bond. Adjacent to that, you will have a carbon atom to which the alcohol will be attached. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today I am back with a new chapter, that is chapter 7 of your syllabus, alcohols, phenols and ethers. So this is your second chapter from organic chemistry. So we have already completed haloalkanes and haloarenes. The next one is alcohols, phenols and ethers. Okay, so you might be familiar with alcohols, right, which is the functional group, you know, it is OH. So alcohols you are familiar with. Then what are phenols we are going to see, and ethers also you might be familiar with the functional group. We'll be studying in detail about alcohols, phenols and ethers in this chapter. So like we have discussed in haloalkanes and haloarenes, the same way for all the organic chapters we are going to do in the same way. That means first we will be beginning with an introduction, then we'll study the methods of preparation of the alcohol, phenols and ethers separately. Then we'll study their properties, that is physical properties as well as chemical properties. Chemical properties means their chemical reactions we are going to study. So the same pattern will be followed for all the organic chemistry chapters, right? So in today's session, we are going to start with alcohols, right? The chapter is having alcohols, phenols and ethers. We'll complete alcohols first, then we'll move on to phenols, then ether. Okay, so what are alcohols? An introduction to alcohols we'll be studying. After that, classification of alcohols, classification of monohydric alcohols. What is monohydric alcohols we'll be discussing, as well as the nomenclature of alcohols. So nomenclature, the IUPAC nomenclature you are already familiar with. We have already studied it in haloalkanes and haloarenes as well. So it's quite similar with that. It's just that small changes according to alcohols we have to change it. That's it. Okay, so let's begin. Alcohols, phenols and ethers have wide range applications in our daily life. Alcohols and phenols are hydroxy derivatives of hydrocarbons. So they are derivatives of hydrocarbons and they are hydroxy derivatives. What does this hydroxy stands for? It stands for OH group. So in general, if I say what is alcohol, in an alkane or in an alkene or in an alkyne, instead of one hydrogen, you will have an alcohol group. For example, let us take CH3OH. Okay, this is derived from CH4, which is methane, right? Okay, so this is an alcohol. Now, phenol means this is your benzene ring. Instead of one hydrogen atom, you have an OH group. So this is called as phenol. So I hope it is clear. Right. Ethers are alkoxy or aryl oxy derivatives of hydrocarbons. What is this in detail? When we start studying ethers, I'll discuss. Now, alcohol serves as solvents for many organic compounds. Starting from alcohols, number of organic compounds are prepared. So alcohols acts as the preparation of many other compounds as well, right? Phenols occur widely in nature. They are used to prepare adhesives and antiseptics. Ethers are used as inert solvents in many reactions. Diethyl ether was used as a surgical anesthetic. So basically it is having a wide range of application. So of course it is necessary to study about alcohols, phenols and ethers, right? So let's begin with the alcohols. So these are hydroxy derivatives, as I said, OH. Hydroxy derivatives of hydrocarbon in which the OH group is attached to the aliphatic carbon chain. They are not aromatic, aliphatic carbon chain. Instead of one hydrogen, you will have an OH group. So that is how alcohol is formed. The general formula of alcohol is ROH. General formula is ROH. So what does this R stands for? This R stands for any alkyl group. So one example already I have mentioned, CH3OH. Okay, another one it can be C2H5OH, right? Any alkyl group can come. Okay, so general representation is ROH. So CH3OH, which is methyl alcohol. How does this name come? In a nomenclature we are going to study. CH3CH2OH, that is exactly C2H5OH itself, that is called as ethyl alcohol. Okay, so this is methyl group, right? Methyl alcohol. This is ethyl group, ethyl alcohol. Okay, clear? So this is hydroxy derivatives of hydrocarbons, that is aliphatic hydrocarbons. Okay. Now classification of alcohols we are going to study. How are the alcohols classified into various groups based on various characters? So we are going to study the different methods of classification of alcohol. So first one is based on the number of OH groups. How many hydroxy groups are there? Based on that, right? How many hydroxy groups present in a molecule? Alcohols are classified as monohydric. That means in that particular alcohol, only one OH group will be there or one hydroxy group will be there, right? Then dihydric means 2 OH will be there. Trihydric means 3 will be there. Polyhydric means more than 3 will be there, right? So the first one is monohydric alcohol. So just now I told monohydric means only one OH group will be there. So they contain only one hydroxyl group in their structure. Only one hydroxyl group will be there. So methanol, CH3OH. As you can see, only one alcohol group, OH group is there. CH3, CH2OH. Here also only one OH is there. So both of these are examples of monohydric alcohol. Next one is dihydric alcohol. Then there will be 2 hydroxyl groups, right? So these compounds contain 2 OH groups in their molecules. So as you can see, this is ethane 1,2-diol. Okay. So here also you have one OH, here also you have one OH. That means totally 2 hydroxyl groups are there. This is called as dihydric alcohols. Now you have trihydric alcohols. That means 3 hydroxyl groups will be there, right? Propane 1, 2, 3 triol. That is in the first carbon atom, second carbon atom and third carbon atom. You have 3 hydroxyl groups. So 1, 2 and 3, hence trihydric, right? Now polyhydric, what it will be? These alcohols contain more than 3 hydroxyl groups in their structure. So this is one way of classifying alcohols based on the number of hydroxyl groups, that is monohydric, dihydric, trihydric, or else if more than that we call it as polyhydric, right? Now the next one is classification of monohydric alcohols in detail we are going to see. So we have already studied monohydric, dihydric, trihydric, etc. Now monohydric itself, in that itself we have further classification. Monohydric alcohols can be further classified according to the hybridization of the carbon atom to which the hydroxyl group is attached. So this classification is based on the hybridization of the carbon atom to which the hydroxyl group is attached. So the first one is compound containing OH group on the sp3 hybridized carbon atom. So the hydroxyl group is attached to the carbon atom which is sp3 hybridized. Okay. So in this class of compounds, the OH group is attached to sp3 hybridized carbon atom. These compounds are further classified as saturated aliphatic monohydric alcohols, allylic alcohols and benzylic alcohols. Now what are these? Let us see. First one is saturated aliphatic monohydric alcohols. In these alcohols, the hydroxyl group is attached to the alkyl group. These compounds are further classified. So it means that it is directly attached to the alkyl group. So this can be an example. CH3OH, it is directly attached to the alkyl group, right? So based on that, you have further divisions, that is saturated aliphatic monohydric alcohols. In that itself you have further classification, that is primary alcohols, secondary alcohols and tertiary alcohols. Okay, so you know how to identify primary, secondary and tertiary carbon atom. Based on that itself we are going to understand what is primary, secondary and tertiary alcohols. Okay, so in these alcohols the hydroxyl group is attached to the primary carbon atom of the alkyl group, that is a carbon atom bonded to one adjacent carbon atom. So the carbon atom which is directly attached with the hydroxyl group is further attached to only one carbon atom, or it can be any other hydrogen atom also, but only one other carbon atom. So the general formula of how to represent it is, as you can see, this is the alcohol, that is a hydroxyl group, and this is the carbon atom which is directly attached to it, which is further attached to only one carbon atom. So this is primary alcohol. Now in this case also, as you can see, this is attached to, the hydroxyl group is attached to this carbon atom which is further attached to 3 hydrogen atoms, right? This is methyl alcohol, this is also primary alcohol. right? It should be either, it can be attached to all 3 hydrogen atoms or else only 1 carbon atom. So you can see CH3, as you can see, alcohol is attached to this carbon atom, which is further attached to only 1 carbon atom. So this is also primary alcohol, right? Now moving on to secondary. In these alcohols, the hydroxyl group is attached to a secondary carbon atom. Okay, secondary carbon atom of an alkyl group, that is carbon atom bonded to 2 adjacent carbon atoms. It will be bonded to 2 adjacent carbon atoms. So let us take the general formula first. As you can see, this is the carbon atom to which the hydroxyl group is attached, which is further attached to 2 other carbon atoms, right? You can see an example here. This is the carbon atom that we are considering. 1 carbon here, another carbon here. It is further attached to 2 other carbon atoms. So this is secondary alcohol. Now what will be tertiary? The carbon atom will be attached to further 3 carbon atoms, right? Okay. So in these alcohols, the OH is attached to a tertiary carbon atom of an alkyl group. That is, it is bonded to 3 adjacent carbon atoms. So as you can see, general formula here. Again, this carbon is further attached to 1, 2 and 3 carbon atoms. So this is tertiary, right? All the groups are methyl groups here. As you can see, it is also called as tertiary butyl alcohol. So these names we are going to study in the upcoming slide. So I hope you are clear with what is primary, secondary and tertiary alcohol. Moving on to the next type of classification under monohydric itself. The next one is allylic alcohol. So this allylic, benzylic, already we have studied in haloalkanes and haloarenes itself, right? So what was allylic alcohols? These are the alcohols in which the hydroxyl group is attached to the sp3 hybridized carbon to which carbon-carbon double bond is attached. These may be primary, secondary or tertiary. Even this can be primary, secondary or tertiary. So what is allylic group? That means you will have a double bond. Adjacent to that, you will have a carbon atom to which the alcohol will be attached. So as you can see here, the double bond is present in between these 2 carbon atoms. And this is your allylic carbon. This is not a part of double bond. No, it is adjacent to the double bond to which the hydroxyl group will be attached. So this is called as allylic alcohol. So this is an example of primary. Why? This carbon atom is the one which is attached to hydroxyl group, which is further attached to only 1 carbon atom. So this is primary. And now this is tertiary allylic alcohol. Now see, again the double bond is here. This is your allylic carbon to which the alcohol is attached, right? The hydroxyl group is attached. And this carbon atom is further attached to 1 and 2 carbon atoms. So it is secondary. Now we have tertiary allylic alcohol. As you can see, this is the double bond. This is the carbon atom which is allylic, right? It is further attached to 1, 2 and 3 carbon atoms. So it is tertiary. So I hope allylic alcohol is clear for you. The next one is benzylic alcohols. So these are alcohols in which the hydroxyl group is attached to the sp3 hybridized carbon atom next to the aromatic ring, not directly attached, next to the aromatic ring. These may be primary, secondary or tertiary. Here also you can have primary, secondary, tertiary. So let's understand. This is the aromatic ring, you can see the benzene ring. So this benzene ring is directly attached to this carbon. Okay, and this carbon is attached to the alcohol group, that is your functional group, right? But this hydroxyl group is not directly attached to the benzene ring. The benzene is attached to this carbon which is attached to the hydroxyl group. So this is called as benzylic carbon. This is your benzylic carbon, not directly attached, right? The next one, this is primary. Why this is primary? This carbon atom is only further attached to 1 carbon atom. As you can see the next one, this is the benzene to which this carbon atom is attached. To this carbon atom, the hydroxyl group is attached. Now this carbon is further attached to 1 and 2 carbon atoms. So this is secondary. Now here also this carbon is your benzylic carbon to which 1, 2 and 3 carbon atoms are attached. So this is tertiary. I hope it is clear. Now moving on to the next classification, compounds containing hydroxyl group based on sp2 hybridized carbon atom. It is sp2 hybridized carbon. Okay, these compounds contain hydroxyl group bonded to carbon-carbon double bond. Okay, so this is directly attached to the carbon-carbon double bond. So the first one is vinylic alcohol. These alcohols contain hydroxyl group bonded directly to doubly bonded carbon atom of aliphatic chain. So one example it is shown here, CH2 double bond CHOH. As you can see here, the hydroxyl group is directly attached to the carbon atom which is part of a double bond, right? It is directly attached to the carbon which is part of a double bond. So this is called as vinylic alcohol, or else this is and sp2 hybridized carbon. So that is with the classification of alcohols. I hope it is clear. Now we are going to move on with the nomenclature of alcohols. So we already know there are two ways in which we can name alcohols. One is the common name, another one is the IUPAC nomenclature, right? Okay. So in common system, alcohols are named by adding the word alcohol after the corresponding alkyl group. So that means if I am taking CH3OH, which is the alcohol, how do you name it according to the common system? It is, you have to name the alkyl group, then end it with the word alcohol. So which is this alkyl group? It is methyl. And you have to end the name using alcohol. So it is methyl alcohol. Now what will be C2H5OH? What is this alkyl group? It is ethyl, right? So it will be ethyl alcohol. So the common name is simple. You just have to name the alkyl group first, right? Whichever alkyl group is here, then end it with alcohol. Now IUPAC system, the names of the alcohols are derived from the corresponding alkanes. From which alkane it has been derived, based on that you have to name by replacing E of the alkane by ol. So what is the suffix when it is an alcohol? It is OL, ol, right? So alkane ends with E, right? So that E has to be replaced by ol. So let us understand which are the rules to be followed. So it's similar with what you have studied in class 11 as well as haloalkenes, haloarenes chapter. It's just that instead of that functional group, here it is alcohol. That's it, right? The longest continuous chain containing the carbon bonded to the alcohol group is selected as the parent chain. So parent chain will be, of course, the chain which is having the highest number of carbon atoms and to which the hydroxyl group is directly attached also. The carbon atoms in the chain are numbered in such a way that the carbon atom carrying the hydroxyl group gets the lowest number. So either you can number it from left to right or right to left, but what you have to make sure, whichever carbon atom is carrying the hydroxyl group, that should get the lowest number. The next one is the position of the substituents is indicated by the suitable numbers. You already know that if there is any other substituents, you have to mention it using numbers like 1, 2, 3, etc. Right. The next one, the alcohols with 2 hydroxyl groups are named as diols and alcohols with 3 hydroxyl groups are named as triols. So if more than one is there, you can name it as diols and triols. Now cyclic alcohols are named using the prefix cyclo and considering the hydroxyl group attached to the carbon of the ring as C1. Okay, so we will be naming it as cyclo. The prefix will be cyclo. Okay, now moving on with the examples. So the first one is CH3OH. So common name, how do we write it? We have to write the alkyl name first, then end it with alcohol. So what is the alkyl group here? It is methyl. So it will be methyl alcohol. Now what is the IUPAC name? It will be based on the alkane which is present, from which it is derived. So which is the alkane from which it is derived? It will be CH4, that is methane. So methane, and we have to end the name, that is the suffix should be ol, right? So it will be methanol, that is methane will be there. And instead of E, you do not have to mention the E, you have to end it with ol. Clear? Right. The next one is CH3, CH2, CH2OH. So we have to number from this side as the carbon atom which is attached to the hydroxyl group should get the least number. So this will be 3 carbon atoms, mean it is propyl, right? So it will be propyl alcohol. IUPAC name will be propan 1-ol. Now why it is propan 1-ol? On the first carbon atom, the hydroxyl group is attached. So it is propan 1-ol. I hope it is clear. Now moving to the next one, CH3, CHOH, CH3. So again, we can number from either side, it will be the same. On the second carbon atom, you have the hydroxyl group. So this is also propane. Right, this is also propane, but on the second carbon atom, you have the hydroxyl group. So this will be propan 2-ol, right? Propan 2-ol will be the IUPAC name and the common name will be isopropyl alcohol. Moving on to the next one, CH3, CH2, CH2, CH2OH. So you can have 1, 2, 3, 4. 4 carbon atoms. To the first carbon atom, hydroxyl group is attached. So 4 carbon atoms means it will be butane, right? So what will be the common name? It will be butyl alcohol, right? It will be butyl alcohol. And what will be the IUPAC name? It is based on butane. So it will be butane. On which carbon atom you have the functional group? It is first carbon atom. So it is butane 1-ol. Moving on to the next one, CH3, CH2, CHOH, CH3. So from which side I have to number? From this side, right? Because then only the carbon atom having the hydroxyl group will get the least number. So 1, 2, 3 and 4. So if I name 1, 2, 3, then this carbon atom will get the third number. So that is not correct. Okay. So that is why we have to number from this side. So what is a common name? It is secondary butyl alcohol. Right, because this carbon atom is secondary. That is why it is secondary butyl alcohol. Now IUPAC name, which is the alkane, that is 4 carbon atoms, means it will be butane. And on which carbon atom you have OH, that is second carbon atom. So it will be butane 2-ol. I hope it is clear. Moving on to the next one, CH3, CH2, CHOH, CH3 you are having. So how do I number it? 1, 2, 3. Okay, so this will be the numbering. It is isobutyl alcohol, and on the first carbon atom you have a methyl group as well as an alcohol group. So this is called as 1-methyl propane 1-ol. So this much is propane 1-ol. We have already discussed here before. On the first carbon atom you also have a methyl group which has to be mentioned, right? So the substituent has to be mentioned first. That will come as the prefix. This is a substituent which will come as the prefix, and the name should end with ol. Okay, I hope it is clear. Moving on to the next one, CH3C, CH3, CH3OH. So this carbon atom is the one which is attached to the functional group, and it is further attached to 3 other carbon atoms. So it is a tertiary carbon atom. Hence it is called as tertiary butyl alcohol. Now why butyl alcohol? Because in total there are a total of 4 carbon atoms. Now how do I number this? Do I number 1, 2, or else do I number 1, 2, 3? So I need to get a principal chain which is having the highest number of carbon atoms. So how do I number 1, 2 and 3? This is how I number. Right. Now on the second carbon atom you have a methyl group as well as the functional group attached. So how do you name this? The alkane will be propane, not butane. It will be propane. Right. So it will be on the second carbon atom you have methyl. So it is methyl, 2-methyl and propane 2-ol. Right, on the second carbon atom you have the functional group. So it is 2-methyl propane 2-ol. Moving on to the next one. Here 1, 2, 3. From either side you can number it. So on the first carbon atom you have an hydroxyl group. Second you have as well as third. So how do you number it? It is propane 1, 2, 3 triol. So this was also discussed. If you have more than one hydroxyl group you have to name it as diol or triol. Right. So you have 3 hydroxyl groups, hence it is triol. So which is the alkane? It is propane. So it is propane 1, 2, 3. In all the positions alcohol is there, right? So 1, 2, 3 triol, right? Just don't write all. It should be triol based on how many OH groups are there, right? The next one, is this benzene? No, it is not benzene, right? It is cyclohexane. Cyclohexane. 6 carbon atoms. 1, 2, 3, 4, 5, 6. So it is cyclohexane. And on the first carbon atom you have an hydroxyl group attached. So this is cyclohexanol. This is called as cyclohexane, right? Cyclohexane, and instead of E you will have ol there. That's it. Now 1, 2, 3, 4, 5. 5 carbon atoms are there. So this is cyclopentane, on which the first carbon atom you have the functional group and the second carbon atom you have the substituent which is methyl. So that you have to mention first. 2-methyl will come. Now what is the rest which is present there? That is cyclopentane, right? Cyclopentane, instead of E you will write ol there. So it will be 2-methyl cyclopentanol. I hope it is clear. Now the next one is CH3, CH2, CHCl, CHCH3, CHCH3, CH2OH. So in this case, from where you have to number? The functional group is here. So of course from that side you have to number. So it will be 1, 2, 3, 4, 5 and 6. 6 carbon atoms are present. Now in this case you have to be careful because you have 2 different substituents. You have 2 methyl groups as well as 1 chloro group. So now how do I mention or how do I name it according to IUPAC name? If you have chloro as well as methyl, which should be written first in the IUPAC name? It should be the one which comes first in the alphabetical order, right? So when you're comparing chloro and methyl, chloro comes first in the alphabetical order. So you have to write chloro first, that is 4 chloro. On the 4th carbon atom you have chloro. So you write 4 chloro, then you write 2, 3. In 2 and 3 carbon atom you have methyl, right? So 4 chloro, 2, 3. 2, 3 dimethyl you have to write, right? 2, 3 dimethyl. And then what is the alkane? It is 6 carbon atoms, so it is hexane, right? And instead of E, you will write all. That's it. So you have 4 chloro first because it comes first in the alphabetical order. Then 2, 3 dimethyl. That dimethyl is also very important. And then pentane, 1 ol. So I hope it is clear. Now moving on to the next part, the structure of alcoholic functional group. Okay. So in alcohols, the oxygen of the hydroxyl group is attached to the sp3 hybridized carbon by a sigma bond formed by the overlap of sp3 hybrid orbital of carbon with the sp3 hybrid orbital of the oxygen, right? So as you can see here, CH3, methanol is the example which is taken, and then you have an OH. So it is just separately written here, and on oxygen you have 2 lone pairs, right? In oxygen you have 2 lone pairs. Okay. Now the figure shown below illustrates the bonding in methanol. The carbon, oxygen, hydrogen, that is this particular bond that you can see, is the angle in alcohol is slightly less than the tetrahedral angle. Okay, sp3 hybridized means it should be tetrahedral. That is 109 degree it should come. But it is less than that. It is not following the tetrahedral angle. Why? Because it is due to the repulsion between the unshared electron pairs of oxygen, that is lone pair bond pair interaction. So we have studied VSEPR theory in class 11, wherein we have studied the lone pair bond pair interactions, bond pair interactions, and lone pair interactions. Because of these repulsions which is taking place, what happens? The bond angle decreases and the geometry will change, that is the shape will change. So as it is sp3 hybridized, it is supposed to be tetrahedral, but because of the presence of these 2 lone pairs, what happens? There will be a lone pair bond pair interaction and repulsion which takes place, by which the angle will decrease from 109 degrees. I hope it is clear. So this is the structure of your alcohol. So in the next session, we are going to study the methods of preparation of alcohols. So from alkenes, from carbonyl compounds, and from Grignard reagent in detail we are going to study. So I hope the introduction to alcohols is clear for you. The concepts that I've covered in this session is clear for you. So that's all for today. Thank you.